Malaysia is leaving behind in sustaining waste management awareness, especially in the region of recycle. Currently, the rate of solid waste increased significantly, and one of the methods that can be done in managing waste effectively is by boosting recycling activities using interactive reverse vending machine (RVM). RVM works by analyzing every deposited recycled materials to the machine and provide rewards to the user accordingly. Previously, a hybrid sensing-based RVM has been developed and tested in municipal office as shown in figure. However, with tedious sensor calibration, maintenance, and considering state-of-the-art real-time detection in computer vision technologies, a vision-based recycled material identification is proposed in this project that utilizes You Only Look Once YOLO version 5 framework. Initially, a bunch of samples of aluminum can, PET bottle, and Tetra Pak were collected, in which the picture was captured from various material orientation and side view. Objective of this study are to construct recyclable waste image dataset of polyethylene terephthalate PET bottle, aluminum can, and Tetra Pak class for RVM detection. Second, to analyze detection algorithm based on YOLO framework that can detect image from constructed datasets with high accuracy. And the third one is to evaluate the performance of the optimal YOLO model in RVM in real-life scenario under lab test condition. This module is using data science process that started with collecting pattern of a particular container, which is will start off by collecting as much data set as possible. After that, train algorithm to learn from examples. It is like we teach the computer how to differentiate cans from Tetra Pak and bottle. If it's like cylindrical shapes, most likely to be a can. If it's in the shape of rectangle, it most likely to be a Tetra Pak. We teach this computer algorithm these features. It can be done with the shapes and the patterns that we have collected from the user into the inlet of the recycle reverse vending machine. A live feed assessment has been done to the system after obtaining optimal YOLO hyperparameters with 0.995 MAP at 0.5 accuracy as shown on the screen. This module also has been tested under several conditions. First is feed 10 samples for each class continuously. For this condition, the recycled sample of aluminum can, PET bottle, and Tetra Pak 10 for each cluster were continuously fed to the recognition module and the output recorded. Based on this experiment, the system obtains 93% accuracy. The misdetection only occurs for aluminum can sample in which it has detected as PET bottle. Second is feed the module with random sequence of material class. In this context, the module is being fed with random sequence of class sample with tests aimed to analyze whether the module is capable to differentiate each of the input accurately. From the experiment, it is found that the module able to accomplish the task with 100% accuracy, and sample snapshot is shown on the screen. Next is module assessment with camera movement, which is left-right, and multiple samples in a single picture. For this setup, the webcam was set up to move from left to right to determine the detection stability of the module when detecting the recycled material, and the result is depicted in figure. It can be seen that the module able to accurately detect all the material as the camera is moved. For the next experiment, the aim is to analyze module capability for detecting in single feed of camera image, and the result can be found in figure. From the figure shown, it can be concluded that the module works well to accomplish the task by successfully detecting all the recycled materials given. Next is module assessment under natural light exposure and with secondary light aided from flashlight. Under this setting, the input image was exposed to natural light without sufficient light in indoor environment, and the result can be found on figure shown. It indicates that without proper lighting, the module is unable to work well, and hence light source is crucial to guarantee system success. Figure on the screen right now shows the result when the module is illuminated with flashlight source during the detection process. It clearly seen that by only using proper lighting, the detection process can be accurately initiated, and hence RVM module shall be crucially equipped with source light. This module will be able to motivate individuals to make the best decision by recycling their drinking containers instead of tossing them in the general waste. Second, boost recycling activities among community with the offering of getting rewards or tokens in return.